Well, welcome back, friends. Today I want to demonstrate how I go about laying out the printed circuit boards for the Pony80. First off, I'll admit I'm not an electrical engineer and I have no formal training in electronics. I just try stuff and keep doing what works. Also, since the Pony80 is designed to run at relatively low speeds, like up to 10 megahertz, I can get away with some mistakes that would be a problem on a faster system. So if you're going to design anything faster, don't pay any attention to me. So I created this new playlist to kind of separate these videos. I'm not sure how many people are really going to enjoy watching me just lay out a PCB, but I wanted to give it an opportunity and see if folks liked it. And if you do, or if you don't, leave a comment below and just let me know, if you want to see more of these, if you don't want to see more of these, if they're too boring, if you want them faster, if you want them more detailed. I'm willing to change up and do what you want going forward. So just let me know down below. So here you see the schematic for the CPU, the clock, and the reset circuits. And this is I'm going to convert this to the PCB. I'm going to place all the components on there, and I'm going to try to make the traces as short as possible. Make it look as clean as possible. I'm going to use the board that I actually designed earlier and I have now as a template, but I'm not going to follow that exactly. So I'm really just trying to show you the methodology that I use to do the design. So with all that said, let's go ahead and get started. So first thing we're going to start with is we're going to convert the schematic to a PCB. And it's going to say, hey, you've got some unfinished nets. Do you want to check them? And it's always a good idea the first time through just to check them because you might have forgotten to connect something. Unfinished nets mean that, like you see here, we've got some warnings on U0 and U1, which are pins on the connector for the backplane, but they're not used anywhere else. So it's just an easy way for you to catch a mistake, make sure that you've got everything connected that you should. It's just, like I said, just a safeguard. So let me pull that back and go back, and now we're just gonna, everything's fine. We don't have anything to worry about here, so I'm just gonna keep on going. What it's gonna do now is it's gonna set out a board outline, and this is rectangular in shape. It's gonna have two copper layers. It gives the start and end, X and Y, and the width. The start X and the start Y, and then the width and the height. I'm just going to keep all that. I can adjust it later if needed. So just to get going, we're going to do that. You notice here we've got all of the parts laid out below, and this is just like sitting down to put together a jigsaw puzzle. The first thing you want to do is set the parts out so you know all the pieces out, so you make it easier to look through and know what you have and know what you need to get through. So I'm just going to move these up here into the board outline, mainly since it won't let us route until we have these on the board outline. And we know this one will go right here because this is the connector and it's always going to be at the bottom. No, we don't want to just move the letters. Thank you. And I'm not being too precise right here. I'm really just trying to get everything inside the boundaries, just so that, like I said, we can route it and get it started on the routing. So there, now everything is in there, and I could, if I wanted to right now, just go up here and do auto route and just let it run through its routine to see how it can connect everything and what it would do. And it may even struggle. So it went from 66% to 62, so it's trying different things. It may not even be able to route everything on this. It may just be a little too complex because we've just sneezed all the parts onto the board. So yeah, you see how long it's taken. It's 92%, 93%. It may finish. Ooh, at 99. It may finish. Let's see. Nope, back down to 94. So, again, this is not optimal. This is not what you'd really want to do. Just throw everything on the board and just hit route. You want to do some logic behind it. At least I do some logic behind it, so you got a clean board. You don't have too many vias where you're going through the board to well, there you go. So it did complete, and it has 66 total vias and 165 connections. So so it did work. It's not the best design. Would it work for our Pony80? It probably would, because like I said, it's low speed. But there's a lot of, you know, vias here to get to the pins. There's a lot of just looping around that probably doesn't have to be done. If you know, look at some of these, I don't know if you can see, yeah, that right there, you know, there's stuff just going around where it shouldn't have to. So what we're going to do is we're going to undo all of this, and just now what we've got here are these thin blue lines, which are the logical connections between pins. So right here we've got address 0 on the chip on the Z80, and address 0 down here on the connector for the back plane. So what I'm going to do is I'm just going to start moving things around and see if I can't get some optimal routing in here and see what we can do. So I'm going to start off just by putting this down over here. Since a lot of the address lines are down here, I want to have the chip closer. Let me get some of this stuff out of here. Let's see here. So there's the Z80, and you know, we've got the clock. Let me go back over to the schematic, because on the Z80 we also have a capacitor here for the power smoothing, and that's capacitor 7, C7. So I'm going to go back over here, grab C7, and just move it over to the power pin of the, there we go. So there's the power pin, and there's the capacitor, and I'm actually just going to rotate it up here just to get it. You notice that now the ground side is there we go, is straight between the clock and the ground on the chip. So it's just again, just trying to get things a little more organized. So we've got that. We also know that we need 4 resistors, 10K resistors, pull-up resistors for the wait, the interrupt, the non-maskable interrupt, and the bus request. So that's resistors 6, 7, 8, and 9. So I'm going to go ahead and move those around and get them closer to the chip, the CPU. Let's see. So 6 is going in between, let's see here, 5 volts and the pin up there on top. So I could move this up here. I could put this down here. Where does that pin go? That pin goes over here. So I think what I'm going to do is first I'm going to move these pins out of the way here. I think I'm going to rotate this over. And if you notice now, I could do that and I get that nice connection. And I'm also going to lift it up a bit because other things need to get down here to these chips, and I don't want to have it right up close to it. I want to give them room to either go through underneath this resistor or go on the other side and come through. So there's 6, and resistor 7 is here, and that is the interrupt to 5 volts. So I'm going to go ahead and actually flip that up here and do that right there. 8 is the non-maskable interrupt, if I'm not mistaken, which is right next to the interrupt pin on the CPU. So I can take that and set it here as well. So there we've got 6, 7, and then 9 is way over here, which is that pin is the bus request. So I'm going to do the same thing. I'm going to flip this over twice and put this somewhere over here. Let me get these out of the way. There we go. And set this up over here. All right. So we know that we've got our clock here. So there is, I'm going to set that right over here. And then let's see which capacitor goes with the clock, and it's capacitor 11. So let's take this C8 out there. I don't know why that's there, but I'll just move that out of the way. I think that's one of the actually C8 is yep, that's the smoothing for the 556. So let me go ahead and I'll rotate that down, and I'll drop that in right here. So that's ready for the 556, and I just got to remember to move those together. But then what did I say? C8 for what did I say? Not C8, that's what that was. The one on the clock is C11. Sorry about that. So I'll take C11, and where's the 5 volts on the clock? That would be right here. So I will also take that and set it right here. And then let's see what else we got. Let's get these pins out of the way, because those are gonna pretty much be last. So then we got a switch between the clocks. So I'm just gonna set this somewhere up here. I'm not sure yet. What did I just do? I don't know. All right, so let me rotate this, and yeah, set this up. Actually, let me rotate that the other way, because you notice that the lines were crossed on that, so that might cause issues. And I'm actually going to take these and rotate them and get the get the pins to be aligned with this a little better. There we go. All right, and I'm going to set this one up here as well, right next to it, because I know that that inverter is used a lot near it. Get this out of the way. All right, so let's see what R1 is. We've got this. Oh, which capacitor goes with the inverter? Capacitor 6. You don't. I mean, these smoothing capacitors, you don't have to put them with the chips that they're on in the in the schematic, but it does help if you're troubleshooting. It just helps to keep them the same. That way you know which one's which when you're looking between the schematic and the PCB layout. So, all right, so we know that we've got our timing circuits and our clock circuits and our reset circuits with the NE556. So let's take a look at that and see what capacitors and resistors we have. Let's start with capacitors. So we've got C1, C2, C3, C4, and C5. And over here we don't have any capacitors. So yeah, so C1 through C5. And C4 is the larger capacitor. So we'll set this off to the side. And notice how that, again, that's crossing. I'm going to go ahead and just flip that around just to try to keep that stuff from the traces from having to go through a via to cross each other. All right, so C1, here it is. And that goes from, you can see how it's going from this pin right here, which is U13, and then this side is going to ground. So let's go ahead and put this up here, but rotate it twice. Now let's actually rotate it back up this way. And now you notice, you know, it's all in line with this. So okay, there's C1. Now C2 is the ground and pin 2. Okay, well, it's actually pin 2, 3, 4, pin 2 and 5. So we'll leave it right there. Capacitor 3 is over here on U111. So let me rotate that once, and I'll set this here. And capacitor 5 is U18. All right, let's move this over. and go up here to U18. There we go. Then we can pull this right back down here. Alright, now let's look at the resistors for that circuit. And we've got resistor 4, resistor 1, 2, and 3. So 1, 2, 3, 4. Alright, so let's pull up resistors 1, 2, 3, 4. Here's 1. And that's going to be 5 volts, and that's going to be U11, which is over here. So we'll move this over here, and I think we'll swap that around and do something like this. There we go. Now R2 is going to pins 2 and between pins 2 and pins 1. So let's move this up some, since it's going between pins 2 and pins 1. Let's rotate it over, and there, we should be able to do that right there. Now resistor 3 is going between pin 12 and 5 volts, or 5 volts is right up here. So let's go ahead and move this over and take R3 here and put it right over here. And then R4 is going to 5 volts and pin 8, which is right down here. So let's move these capacitors down a bit. Rotate that over and set him over here. Actually, if we move capacitor 2 a bit, rotate him back over, we might be able to fit him right in here. There we go. Alright. Let's get that out of the way. I don't know what resistor 5 is. So 5, 10, 11, and 12. Let's take a look at those. Here they are. 5, 10, whoops. 5, 10, 11, and 12. And some, I meant to point this out and I forgot. So if I highlight these resistors over here on the PCB, they'll actually, no, they won't. Oh, they didn't stay highlighted. So if I highlight resistor 10 right over here and go over here, usually it's not staying selected. I'm not sure what's happening there. So ignore me. Okay, so those are for the halt LED, the clock LED, the reset LED, and the wait LED. So we really, those LEDs are going to be going out through these pins. So let's take these pins and set them up here so that they're close to this chip. So we've got clock, halt. This one is wait LED. This one is the reset LED. And something else you can do here is if you highlight all of these, you can go up to format and do like align vertical centers, and it'll put them all in line. And then you can also distribute vertically, and it'll make them all even. So so now we've got the LEDs, the LED resistors. So I'm going to go ahead and swap these around, swap these around, put them over here. That one goes there. That one goes there. And this one goes up here. And then again, highlight all those vertical centers and then distribute vertically. And then there, now they're all situated. Now this is the output for the reset switch. And so basically, if you short this out, it goes up here to pin 8 and between pin 8 and ground, and causes the whole thing to reset. So we've got that there. So this is everything laid out, and it's got a lot of white space in here. Again, I'm not doing this exactly as I did for the board layout. So let me save this, and then let's go up and do an auto route and see exactly how many vias we've got and what the board looks like. Remember, we had 66 vias when we just sneezed on it. There, now we have 15. So that's a lot better. And if we take a look at this, you can see, let's turn off the bottom layer here. So the top layer, you know, you've got some wraparounds here. I try to avoid those, but you know, again, sometimes you can't if you've just got a lot of pins to connect. Take a look at the bottom layer. Yeah, and then the last thing that I want to do is I want to put a copper area in there and make it the ground plane. So if I just go up here and start selecting or clicking here and then going back, there we go. Oops, I created it on the bottom layer. I mean on the top layer. I want to change that to the bottom layer. And there we go. Now we've got the ground plane on there. So let me save that, and then I can click on the 3D view. Yeah, and there we go. So now we've got our pinouts. We've got, you can see all the traces and the ground plane. Yeah, so it looks pretty good. I think I would clean this up just a little bit more before I send it off. I would want to get some ground plane inside here. Not a big deal. And then this looks pretty good though. And yeah, so I think that's about it. So again, if you want to see more of stuff like this, let me know. Put it in the comments, and I'll definitely work more on this if it's wanted. Because it's something that I have to do when I design the boards, so I might as well just record it as I'm designing them rather than have to do it twice, once for a video and once for the design itself. So yeah, if you want to see that, let me know. Anyways, have a great time, and we'll chat later.